Hey guys, welcome back to another video. Today I wanted to start a new series of video supplements to go alongside the Aviation Maintenance Technician General Handbook. This handbook is used almost universally among airframe and power plant technology students studying for their AMP license in the United States. A PDF version of the 2023 edition, Foxtrot Alpha Alpha-Hotel-8083-30 Bravo, which is the most current edition as of the making of this video, is available for free on the FAA website, link in the description. It's also the edition these videos will be based on unless otherwise noted. I'll also provide a link to the paperback copy available new on Amazon.com, which is useful if your school requires you to have one, or if you simply prefer learning from a physical book. The Amazon link is non-affiliated, so if you find a better price somewhere else, by all means go for that instead. So with all that out of the way, let's get into it. Aviation maintenance technicians, or AMTs, are routinely involved in the ground handling and operating of aircraft. They also must be skilled in the operation of complex ground support equipment. It's not unusual for aircraft mechanics to occasionally perform the duties routinely designated to fuelers or ramp agents. This work demands a strong grasp of safety procedures for aircraft servicing, taxiing, and equipment operation in order to eliminate, or more often, just mitigate hazards. This chapter also introduces us to human factors and the role they play in maintenance performance. Issues such as fatigue, deadline pressures, and distractions can negatively impact safety and compliance. Technicians must understand these challenges and how to address them proactively to maintain both performance and safety in hazardous environments. This video will cover the first chapter topic, shop safety. So really quick, before we get into the operation of specific equipment, let's go over some general safety information. Clean and organized workspaces are vital for maintaining safety and efficiency in aviation maintenance. However, the round-the-clock operation of many aircraft maintenance facilities can make this difficult. Technicians from the outgoing shift are responsible for properly storing all tools, equipment, and materials not immediately needed by the incoming shift to prevent hazards and ensure readiness for the next team. Any equipment that's being turned over to the incoming shift should still be removed from the aircraft, and the incoming team informed of its presence and location. Workplaces should incorporate clear safety measures, including hazard signs and markings. Signs identify dangers and provide crucial information such as the locations of first aid and fire equipment. Painted safety lines and pedestrian paths further enhance safety by guiding foot traffic away from hazardous areas. Safety in aviation maintenance is a shared responsibility. While everyone plays a role, supervisors and technicians must take extra care to monitor their surroundings. Open communication is essential. It's important to address unsafe behaviors immediately to protect both individuals and the team. Alright, moving on to the next section of shop safety, which covers the physiological dangers posed by working on or around electrical systems. Working with electrical equipment presents serious safety risks. Electricity can cause severe burns where it enters and exits the body and may damage or destroy the nervous system. To mitigate these risks, technicians need a solid understanding of electrical principles and must respect electricity's dual ability to perform work and cause harm. Using the correct safety equipment is essential for technicians working with electricity. Personal protective equipment, PPE for short, such as rubber gloves, safety glasses, and grounded mats not only protect physically, but also provide confidence, helping to maintain focus and caution. Two primary factors that lead to electrical accidents are fear and overconfidence. While respect and confidence are necessary, extremes of either can be dangerous. A lack of knowledge often leads to insufficient caution, while overconfidence promotes unnecessary risk-taking. Proper education and awareness are crucial to ensuring safe practices when working with electricity. Moving on, let's talk a little bit about the fire hazards presented by electrical systems. Whenever electrical current flows, heat is generated as a byproduct. Higher current levels produce more heat, which can melt protective coatings on wirings and lead to short circuits. which in turn leads to greater current flow. This creates a dangerous cycle of increased current, more heat, and a greater risk of catastrophic failure, including melted metals, vaporized liquids, and fires. Preventing electrical fires starts with maintaining a clean and organized workspace. Keep the area free of flammable materials and ensure power cords and wires are handled properly. Kinks, bends, and physical damage weaken wires, increasing heat generation and subsequently the risk of fire. Close monitoring of electrical equipment is crucial for safety. Regularly inspect wires, cords, and devices for signs of wear or damage. If issues are identified, repair or replace the equipment immediately to avoid accidents. Neglecting maintenance can lead to overheating, short circuits, and potentially devastating fires. That concludes the electrical safety portion. Next, we'll cover the hazardous properties of compressed gases and some safety precautions we should use when working with them. Compressed gases, like electricity, are valuable tools when handled properly. To ensure safety, inspect air hoses frequently for damage, maintain leak-free connections, and regularly serve as inline oilers and water sumps. For paint spraying, always pre-filter the air to remove contaminants like oil and water. Compressed air must be used responsibly. Never use it to clean hands or clothing, as this can embed debris into the skin, leading to infection. Similarly, avoid spraying near others to prevent accidents. When finished, always straighten, coil, and store air hoses correctly to reduce hazards. Servicing aircraft tires with compressed gases requires extreme caution. Always use tire dollies to manage heavy tires and inflate uninstalled tires within a tire cage to protect against overinflation injuries. High-pressure air systems must have regulators. I'll briefly explain pressure regulator operation in case you're unfamiliar. In the regulator pictured, the pressurized gas reservoir or bottle would hook up to the left side of the regulator, and a fluid line, typically a flexible hose, would be connected to the right. The left gauge, that is the gauge closest to the reservoir, would read reservoir pressure, and the right gauge, the gauge farthest from the reservoir, would read the pressure in the hose. The pressure in the hose can be increased by rotating the control knob clockwise and bled off by rotating the control knob to the counterclockwise extreme. For anyone curious, from doing some further research, I believe the portion of the right side that juts out at an angle is a hose failure valve, which serves to bleed off pressure automatically if the hose develops a leak. I haven't personally seen this on the pressure regulators I've used in the field, so don't worry too much about that. Let's go ahead and move on from compressed gases to hazardous materials. Material safety diamonds, which should be placarded on hazardous materials, are critical to maintaining shop safety, offering a quick way to understand the risks associated with a specific material. Each segment of the diamond represents a specific hazardous property. Red for flammability, yellow for reactivity, blue for health, and white for special hazards, such as radiation or carcinogens, to name a few. These labels also guide the appropriate use of safety equipment when dealing with the hazardous material. Regardless of the hazardous properties, or lack thereof, every material safety diamond will feature all 4 segments. Each diamond segment has a hazard rating from 0 to 4, with 0 indicating minimal hazard and 4 indicating extreme. The white segment highlights specific hazards with codes like Romeo Alpha Delta for radiation or Charlie Alpha Romeo Charlie for carcinogens. These symbols offer quick and precise hazard recognition. Safety data sheets, or SDSs, provide a detailed guide to handling hazardous materials. They include chemical formulas, health effects, and steps to take in case of exposure. SDSs feature standardized information and are essential for maintaining compliant safety practices. You may hear reference to material safety data sheets, or MSDSs. Please note that the safety data sheet, SDS, is the new replacement provision for the former material safety data sheet, MSDS. Moving on to the final subsection of the shop safety topic, we'll be looking at safe practices when operating some common machine tools. More specifically, we'll be taking a closer look at drill presses, lathes, milling machines, and grinders, as well as touching on quite a few welding precautions. The drill press is a versatile tool used for tasks such as boring, reaming, facing, and milling. To ensure safety, always wear proper eye protection and securely clamp your work. Adjust the drill's revolutions per minute, RPM, depending on the material you're working with, and never exceed the spindle's travel limit. If adjustments or jam removals are needed, stop the machine first. Finally, restore a clean work area after completing your work with the machine. Lathes are essential tools for shaping cylindrical objects, with operations possible on both the inside and outside of the workpiece. The rotary motion is achieved by securing the workpiece in a chuck and rotating the workpiece itself, while forming is performed with a securely mounted tool such as a stationary drill bit or cutting tool. To ensure safety, always wear eye protection and use sharp cutting tools. Never attempt to stop the chuck manually. Instead, allow it to stop on its own. Inspect tools and materials for any cracks or defects before beginning. Additionally, never place tools on the lathe, as they may be caught and thrown by the machine. Finally, always wait for the workpiece to stop completely before taking any measurements. Milling machines are versatile tools used for work such as shaping or dressing materials and cutting gear teeth, slots, and keyways. To ensure safe operation, always wear eye protection and start by cleaning the workbed. Secure the workpiece properly to prevent movement during milling, and choose the appropriate tools for the task. Never attempt to change the feed speed while the machine is operating. Before moving under or away from the workpiece, lower the table to avoid accidents. Lastly, confirm that all clamps and bolts are positioned so that they may pass freely under the arbor. Next up, grinders. No, not that kind. Calm down. Grinders are essential for tasks such as sharpening tools, dressing metal, and removing small amounts of material. For safe operation, always wear eye protection, even if a shield is present. Inspect the grinding wheel for defects before each use and ensure it fits snugly on the spindle with minimal force. Avoid applying side pressure to the wheel, as this can cause it to shatter. Always check that the wheel flanges and compression washer are appropriately sized. Roughly 1/3 the diameter of the wheel is what we're looking for here. Lastly, as a safety precaution, do not stand in the arc of the grinding wheel during operation to avoid injury in case of wheel failure. The final part of the shop safety topic covers aviation welding practices. This first slide will cover work performed on parts first removed from the aircraft, which should be the case whenever possible. All part-off aircraft welding should take place in a designated welding area with a controlled environment, such as in a welding shop. This area must feature proper tables, ventilation, tool storage provision, and fire prevention and extinguishing equipment. So what happens if the part must remain on the aircraft during welding? Firstly, if the aircraft can be moved outside and welding performed there, that would save us quite a headache, and that should definitely be done. If part-on aircraft welding must be performed inside the hangar, that's where we need to worry about all the following stipulations. Welding must not be performed near open fuel tanks or fuel systems, or in any area where painting is currently or has recently been performed. 35 feet of clearance must be maintained between all aircraft and the location of welding. The area must remain free from flammable materials, and only qualified welders are permitted to perform work. Before starting work, secure the welding area with ropes and placards and ensure primary and backup fire extinguishers are available. The minimum rating for the primary extinguisher, that is the extinguisher in the immediate area, is 20 Bravo. A backup extinguisher must also be available with a minimum rating of 80 Bravo. In this case, Bravo denotes the extinguisher is designed to put out chemical fires, and the preceding number 20 or 80 denotes the square feet of fire that a non-expert user can be expected to put out using the extinguisher. During welding, trained fire watches must be in position and the aircraft must be in towable configuration. Towable configuration, for our purposes, means a tug is attached and manned by a qualified operator, the aircraft parking brakes are released, and mechanics are available to assist. The hangar doors must also be open. Alrighty, that concludes the first topic of Chapter 1 of the Aviation Maintenance Technician General Handbook, Shop Safety. Hopefully everyone's still awake, and if not, hey, at least you can use this video for future insomnia relief. I find that the General Handbook information can be pretty hard to digest, as it's just a bunch of information, and it may not be as interesting as the information contained in the airframe or power plant handbooks. Nonetheless, the information is important for working in the aviation maintenance field and for passing the required testing to get licensed. Hopefully this presentation style helped make the information stick a bit more than just reading the information out of the textbook raw. Feel free to let me know what you think in the comment section below, and if you'd be interested in my continuing this video supplement series. Thanks for watching, and until next time, wrench on!